Okay, so these are your 30, 60, 90, 45, 45, 90 triangles, which again won't be on the quiz, but they will be on your test and the part that you take next Wednesday, the non-calculator part, because these are kept exact. Hang on. Okay, wait, did I send my attendance? Yeah, okay. It's on the Zoom thing, but okay. You said 8, 15, 17. That's like the most obscure one, Madeline, but good job. 3, 4, 5. 6, 8, 10. 5, 12, 13. 7, 24, 25. Somewhere. Yeah. You need them in your brain. I'll be very honest. If you plan to take a standardized test, you need them in your brain. But for the next 24 hours, you can write them somewhere that you can use them. So that's going to help you with at least one of your triangles or coordinate points. I promise you'll see some sort of triple. Just pay attention to your signs on something like 6 and 7. All right, then these were your Pythagorean identities. That should be identities, not identifies. To find, remember these, you want to do sine squared plus cosine squared, I should say sine squared theta, plus cosine squared theta equals 1. Tan squared theta plus 1 equals secant squared theta. And 1 plus cotangent squared theta equals cosecant squared theta. So that's what you're going to use to set up 8 and 9. And you also need your quadrants. Remember, all students take calculus. With the sine comes the cosecant, with the tangent comes the cotangent, and with the cosine comes the secant. Those represent the ones that are positive in those quadrants. So when you see something like number 8 where it says it's in quadrant 2, I would know that the sine and the cosecant are positive in quadrant 2, but everything else would be negative, and that tells me what to pick on my sign. Questions about your quiz tomorrow? Because I do want to jump into a little bit of calculator work, and then I'll let you come back to this. Yep. What do you mean circle stuff?
Like the sine of 90 degrees is equal to...
No. No, because you could literally set up a chart and answer it. Yeah, no, there'll be more of an application of it. When we get into the test, they will be like coterminal angles of that. Like instead of it saying sine of 90, it might say sine of 425 or something like that, where you've got to go around your circle. Yeah, but we'll say that for the test. Okay, so whatever calculator you have with you, I want you to take it out because we're going to practice some of the calculator questions. Some of this you have definitely done before, and then some of it has a bit of a twist, and those are the ones that I really want to focus on. No, so this is going to be on the calculator portion. So we're talking next Friday, but you're going to see this while I'm gone, and I just wanted to at least introduce you to it. Two parts, yep. Wednesday is the first part, the longer part, no calculator. Friday of next week, which is early release, is the second part, but it's only like 20 minutes. And that's the calculator part. All right, so these, right, like think back to what we know about our calculator. If I wanted to find the sine of 316.5 degrees, I literally just type that in. Sine 316.5, hit enter. And I get negative 0.688. We're going to say keep 3 decimals. So these you have done before. Hopefully we remember those from geometry. You literally just type that in. Then you get reciprocal function ones like secant, which would have to be typed in as what? 1 over cosine of 142 degrees in 15 minutes. So the first thing I have to do is convert that. 15 divided by 60 is 0.25. So this is the same thing as cosine of 142.25. Negative 1.265. If it was cotangent, I would do 1 over tangent. If it was cosecant, I'd do 1 over sine. Then I get tangent of negative 37. I type it in exactly like that. Tangent of negative 37. And I get negative 0.753. Easy stuff, right? Questions on that? Okay, then it gets a little bit trickier because we flip it. So now we're finding the angle measurements given the trig functions. So this is like the end of what we did yesterday. Remember yesterday we said something like find cosine of theta if my trig value is a half, right? So I'm looking for the angle on my circle from 0 to 360 in which cosine is a half. Do you remember these from yesterday? It's been like a whole 26 hours. Do we remember it? Yes? And we had to find theta, right? So we used, hang on just a second, Vanessa. We know we use the triangles. This would be a 30, 60, 90 triangle. This is 1, root 3, and 2. So the cosine would mean that the 1 is adjacent to this angle, which means I'm talking 60 degrees. But we have to give from 0 to 360. So not only do we have to include first quadrant, we also have to include, where else is cosine positive? Fourth quadrant. So we also have to include fourth quadrant, which would be 360 minus 60, or 300. So there's 2 answers to this question because there's 2 places on my circle in which cosine is positive. Now that's without a calculator, right? We use the triangles. Now we're going to do with the triangle, but we have to keep in mind the reference angles still. Vanessa, if you had a question.
Okay, could you go back to the...
You're welcome.
Can you state it?
Yep.
Can you just explain the tangent one, like C? Can you just like explain how to put it in?
You literally just write tangent and then negative 37.
Okay, because I'm getting something different. Like I don't get that. I got something different. I get something different for all of them.
Are you in the right? You're in radians. So your mode, check your mode. Click on mode and make sure it's degrees. You see radians to degrees? Switch from radians to degrees.
Oh, I see.
Well, I'm glad we had this conversation because you would have gotten every single question. Not tomorrow because you won't use it, but on Thursday when we start solving right triangles, you would have gotten every single question wrong.
Wait, let me try.
Yeah. If you hit the sine, the cosine, or the tangent button, you have to pay attention to what mode you're in, and for these you have to be in degrees. Eventually we will deal with radians, but for right now we have to be in degrees.
Okay, it's good.
Now it's good, right? Okay, good. So I don't know if that happened to anybody from home, but you want to be practicing this with a calculator because you have to be in degrees for these. So in chapter 6 we're going to talk about radians, but for now we're talking about degrees, and your calculator has to be in degrees, which will highly impact Thursday's portion of the notes. Not so much tomorrow because you're not using that calculator, but
Mine just says comp stat table.
no, you want to go to, it's the different mode. Your mode, you might have to set up.
Or do you have to
So hit the button. So see how it says 3 there's degrees? Hit 3.
Yeah, it should.
Okay. And now do it. Yeah.
What do I do after?
You went to degrees. So setting quick gets you out of that menu,
I found out.
and then try it again. Yeah.
Do like the whole like second part thing under the yellow one? Like the whole thing?
Right. The green part, or what we're about to do.
The green.
The green part. So if you don't have a calculator, so this kind of question would be on the non-calculator portion next week, right? I give you the answer, you have to give me the angle.
Oh.
So that's what that is. So if the cosine is a half, tell me which angle that is. That's when you set up your triangles. You figure out which angle it would be, where adjacent would be 1 and opposite would be 2.
Okay, I thought
And-
you were solving the other.
No, now we switch, right? So this would be non-calculator portion, non-calc, and that's what we talked about at the end of the day yesterday, right? Now we're in calculator portion. The reason I introduced that is that think all of these are going to have 2 answers because it's from 0 to 360. And your calculator doesn't know to tell you that it has 2 answers. You have to remember that it does and then find the reference angle. Does that make sense? How do you switch the mode? Helen, it depends on what calculator you have. What calculator do you have? Can you show me what kind? It's like the pink one. Hit where it says DRG next to second. There's a little button that says DRG, and then make sure that DEG is underlined. Did it work?
What's the other one? There's DEG, radians, and...
Gradients? We never even use it. Somebody must, but not us. Okay. All right, so again, I'm going to say that again just so that you understand what we're about to do. When we talk a non-calculator question, and I give you a trig function, let's say I said sine of theta is negative a half. There are 2 places on my circle in which that answer is correct, right? I'd have to set up my triangle like this. I'd have to figure out which angle has opposite it the 1 and the hypotenuse 2, and that's the 30 degrees. I would say sine is 30 degrees is my reference angle, but it's not negative in the first quadrant, right? Where is sine negative? Mm-mm. 3 and 4 is where sine is negative. So I have to take this 30 and add it on to the 180. And I'd get 210. That's one answer. And then I'd have to take the 360 and subtract 30 from it. And it's 330, and that's the other answer. So I use my 30, 60, 90 triangle to get the reference angle, but then I've got to figure out what quadrant it lies in to figure out the real answer. Do you understand what I'm saying? Because it's gonna get real confusing if you guys are not with me
So
when I go into the calculator.
From the triangle, you're gonna tell us if it's sine, cosine, tangent, and like that stuff.
Mm-hmm.
And then you're gonna tell us like what it is, and then from there, if it's negative or positive, we decide what quadrant it's in.
First, you figure out well, yeah, sure, it doesn't matter what order you do that in.
And then based off of that, we decide what angle it is, and then from that, we usually get 2 answers, sometimes 1.
Right.
And then we will figure out how to put it in.
The calculator is the process is the same. No, the process is different. The understanding is the same. So the calculator, we don't use the triangle. We have to use our calculator. Does that make sense? So if I ask you to find the cosine of theta that has a cosine, or the theta, that cosine is 0.4675, you would normally in your calculator do cosine -1 of 0.4675. So I would do second cosine, because when I'm looking for the angle, I hit the -1 buttons. So second cosine 0.4675. And I get that theta is 62.1278, so 128 degrees.
Why did we do the second?
Because if I hit the button, it says find the cosine of this angle. When I hit the inverse, it says find the angle that has that cosine, right? Because the unknown here is the angle. We know the cosine. Does that make sense?
Mm-hmm.
So if it says trig function of theta, you're doing the inverse ones. But again, because we're going from 0 to 360, that is not the only answer. You guys, I'm going to stop. And you're going to get so confused on Thursday when you have to figure this out on your own. I need you to pay attention. Whatever it is you've got going on, you need to stop and focus. It's 15 more minutes and then you get your day. But I'm doing this so that you are not confused on Thursday. If you don't at least lay a foundation with me today, you're going to be even more confused. So please, I am begging you to stop whatever it is you're doing and pay attention. I'm going to start it all over again. I swear you're going to be so confused if you don't understand this. Start with a non-calculator question. How do I find this?
Are you trying to find the angle of theta?
How do you know you're trying to find theta? Because it actually says theta and I know sine. That's the difference between that, right? These are two different questions, yes? On the right, I'm hitting the actual sine button, and if I had if it just said sine of 30, I would just use a triangle, right? And I would find the trig function. On the left, I have the trig function, I need the angle. Do you understand the difference? Yes. Okay, so now how do I find theta if I know the trig function? The only one that has a root 3 is the 30, 60, 90. So that one tells me already to use that one. 1, root 3, 2. Which angle gives me opposite and hypotenuse, where the opposite is root 3 and the hypotenuse is 2? 60 degrees. So theta is 60 degrees. But is that my answer? No, that would actually be completely wrong. Why?
Because it's just your reference angle.
That's just my reference angle. It's not positive. Right? So that if you actually hit sine of 60, it is not negative root 3 over 2. It would be wrong. So I have to use that reference angle, but find where theta has a sign that would be negative. So where is sine negative? It's in the third quadrant and the fourth quadrant. So if my reference angle is 60, that means I have to go past 180, 60 degrees. So I do 180 plus 60, and I get 240. And if it's in the fourth quadrant, I'd have to go 60 degrees away from 360, so it's 360 minus 60. So the two answers to this question are 240 and 300. Do you understand that part? Yes. Yes. Okay. Now we're going calculator. So if I said cosine of theta equals 0.4675. Before you even figure out what angles there are, what two quadrants are my angles going to lie in? 1 and 4. And how do you know that? Because that's where cosine's positive, right? So my calculator is going to give me the first quadrant one. I'm going to do cosine negative 1.4675. Because I'm looking for the angle this time. So when we want the trig value, we hit the regular button. When we're looking for the angle, we hit the second. So this is 62.1278 or 128 degrees. And that answer is one of my answers because I'm in the first quadrant. But then the second one comes from what? Fourth quadrant. How do I find the angle in the fourth quadrant if it's the reference angle? What do I do with that 62.128?
Wait, so why do you know cosine to the negative one?
Because I'm looking for the angle, right? The angle is my unknown.
Okay. How do you put the negative one in the calculator?
Second, cosine.
I did that, but I like this.
Does yours give you it on the top? Are you in straight? Yeah, no, yours is different. So you hit here. You hit trig, second, trig, and go all the way down,
Oh.
and you'll see the negative one. You're welcome. So if the reference angle is 62.128 and I want to find the actual angle in the fourth quadrant, what do I do with that 62.128? Good. Subtract it from 360. So 360 minus 62.128. 297.873.
Will we have angles like that are like weird?
Yep. On Friday's portion, on the calculator part. These take 5 seconds to check because all I have to do is cosine of 62.128 and I should get my question, which is 0.475. And then I do cosine of 297.873 and I get 0.675, which is my question. It won't be exact because we round, but it should be pretty close.
Why did you
Cosine.
Oh.
Yeah, cosine. Let's try another one. Actually, let me try another one before we get to sine, that next one. All right, so let's do sine of theta equals 0.456. What two quadrants are the angles going to come from? 1 and 2. How do I find the first one?
Just the sine -1.
Good. Second, sine 0.456. And theta is 27.129. That's the first one. How would I find the angle using that 27.129? That's in my second quadrant.
180 minus that.
Good. 180 minus 27.129.
I know it's in second quadrant.
Because that's the only other quadrant in which sine is positive.
Oh. And so then why would, do these follow like the same rules from that one slide in our notes, where it's like where it's the same, the 180 minus
Yep.
180?
Yep. Second quadrant's 180 minus theta. Third quadrant's 180 plus theta. Fourth quadrant's 360 minus theta. Yep, same rules. Are we getting warmer?
That second answer is the 180 minus 20.
Correct. Okay, so now what happens if it's negative? So let's say that cosine theta is negative 0.375. Let's just make some stuff up, okay? What two quadrants is this angle going to be in? 2 and 3, right? Those are the two places that cosine's negative, right? Does that make sense? So the first answer my calculator gives me is not even an answer because it's going to give me the first quadrant one. Does that make sense? So I'm going to do second cosine negative 0.375 and I get 112. Oh, this is a bad example because it gives you 1. It's going to give me this, right? And I'm going to explain what's the deal with this. This is the one that's in the second quadrant, right? So there's two ways to do this, is figure out that that means my reference angle would be 180 minus that, and then add that onto the 180 to get the one in the third quadrant, which I think is confusing. And I taught both methods on the notes for Thursday too. My advice is don't even put the negative in when you find your first angle. So do what we did, figure out what two quadrants they're going to be in, then do second cosine of 0.375, and you get theta equals 67.976. But remember, that's your reference angle. That's not your answer. Then to get the second quadrant one, you're going to do 180 minus that. And to get your third quadrant one, you're going to do 180 plus that. 180 minus 67.976. And I get that 112.024, which should make sense. And then 180 plus 67.976. And I get 247.976.
I don't know why.
Wait, hang on. Madison, what part?
Just kind of what you did right now. After you got the 112.
So I said that gives you your second quadrant one, but in order to figure out the third quadrant one, you'd have to figure out what that reference angle is and then add it to 180. Which is fine, but I actually think that's more confusing. I would take the approach of finding the cosine of the positive value and then use that reference angle to subtract from 180 and add to 180.
Right.
So when it's negative, just
Make it figure out what quadrant it lies in first,
Figure out what quadrant it's in, plug it in.
as though it's positive,
Positive.
and then find it in those 2 quadrants. Yep.
And when you're doing the ones with negative, you don't do like cosine for -1.
No, you still did.
Oh, you still
Yeah.
do that? Okay. So for all of these, you're putting it to -1.
Yep. Everything that's looking for theta, we do.
Okay.
Okay, tangent, negative 2.45. What quadrants are these going to be in? 2 and 4. So I'm going to do inverse tangent of positive 2.45. And I get theta is 67.797 when rounded. And again, that's just my reference angle, so that is not an answer I can use because it's not, this would not give me a negative tangent. So now I take it, in the second quadrant I would do 180 minus it, and in the fourth quadrant I would do 360 minus it. So 180 minus 67.797, that's 112.203. And 360 minus 112.203, 247.797.
Why is it not negative?
Why is the angle not negative? Because your range is 0 to 360. So it will never be negative. Questions on that one? We're getting a little bit more of an understanding of it so that by Thursday when you see it again on the video, maybe it'll be like, oh, this is what she meant. Yes, okay, that's my goal. There's one more thing and I'll show you and then I'm going to shut up. And that is something like this. Sine of theta equals 1.25. Yep. Okay, if you remember, just let me know. All right, so if we follow like we've been doing, what would we do here? Figure out the quadrants. Where is sine positive? 1 and 2. And then I'd do what?
Plug in sine to the negative first.
Go ahead, do that. What happened?
Error.
Error. Why are you getting an error?
Because it's wrong.
Mm-mm.
The whole number. I mean, not whole. It's not like it's bigger than 1.
Can sine be bigger than 1? Think about what you're saying. If you say sine is bigger than 1, you're saying that your opposite side is bigger than a hypotenuse. Can your opposite side be bigger than a hypotenuse?
No.
No. Sine and cosine cannot be, so this is no solution. Sine and cosine cannot be greater than 1. Ever. You're literally saying the hypotenuse is smaller than the opposite side or the adjacent side, and that can't happen. The hypotenuse has to be the longest side.
Well, what if it's bigger? What if the hypotenuse is like?
Can't be.
It's still because
It has to be bigger. Even if it's like 0.1 bigger, it has to be bigger. So sine and cosine can never be 1 or greater than 1. It always has to be less than 1. Okay? So these questions, instead of putting them with the 5-3 homework, we put them with the 5-4 homework. They will be on the 5-4 video. Okay? I'm sorry if I make your head hurt, but I want you to get a little bit of an exposure to it before you get super confused on Thursday. The easy stuff is tomorrow. That's the good news. Just focus on your quiz review. When you come in tomorrow, I'll answer questions on that review, and then you'll take your quiz. Good. Bye, guys. Have a great day.